Welcome to the series that saves you plenty of bugs and helps you reduce your ecological footprint. We should never forget that the boards we use with all their foam, fiber and the epoxy resin are, once broken, toxic waste. So we should rather repair and modify them in order to be able to use them longer instead of getting new ones all the time, shouldn't we? This is episode 4, and in this episode we will address another of the biggest issues in windsurfing construction: soft areas under your heels. I will show you a modification you can do to your foot pads to make them extremely reduce impact forces of your heels crashing onto the foot pad. If you want to go directly to the practical part, then click here, and if you're interested in the theoretical background, then stay here. By the way, sorry for the background noises, we're in Spain right now and it's difficult to find a good place to shoot. Anyway, while windsurfing, our heels are pressing or even crashing onto the footpad all the time, especially when we're doing jumps. And the normal footpads are doing quite an okay job by taking off the force peaks of the crashes, because the compression of the footpad takes force. So what can we do to improve this? We can take thicker footpad in order to make the force peaks that get cut off bigger. Or we can enforce the deck with some extra lamination to make it resist longer. But there will still be two problems. First, once the footpad is compressed to the maximum, there's still quite a solid heel crashing onto a solid deck. And solid on solid is never a good idea. And secondly, the force that's dealt is quite punctual, and that's also not a good idea. So let me tell you how we can improve that force management ability of the footpad. We integrate the layer of lamination into the footpad. We put a base layer of footpad made of EVA foam, that's what most footpads are made of, under the lamination. Then we put the lamination and then another layer of footpad. And what happens then is the following. The heel crashes onto the top footpad and the force peaks get cut off. That's what a normal footpad does. But then the remaining force gets onto the lamination and gets distributed to a larger area, which is a really great thing force-wise. And then what's remained of the force goes into the base pad in a larger area. So it's reduced, distributed, goes into the base pad and is reduced again. And you can imagine that what is left to crash into the deck is almost zero. So this is much better than just using a thicker footpad or enforcing a deck with extra lamination. This highly improves the impact management ability of the footpad. Let me show you how to do this in the practical part. Now before we go into the practical part, let's watch this clip of a hammer banging onto the upgraded pad again. Notice how the deformation of the pad happens in a bigger area, demonstrating how the forces are distributed to a larger area, and notice how the hammer doesn't get through to the table. Compare that to a footpad of approximately the same thickness, while I tried to use the same force on both pads. If you ask me, this is pretty awesome. In case you're not using your original footpad from your board, you can get a footpad like this off eBay. Take care that because of the structure of the footpad, you can't cut out your new footpad in any direction. In case you're using your original footpad, use them as a template. Otherwise, I recommend making wood templates. Here you can see me dealing with the problem that the footpad I bought is not wide enough for the front footpad, and you can see me figuring out in which angle I should put it on to make the surface structure prevent the feet from slipping off the footpad. Draw the outline of your template on the raw footpad. Cut them out about half a centimeter off the line. This will save you a lot of trouble. Now this is the material I mentioned before. It's 5mm EVA foam. You can get this off eBay as well. Cut out the exact same outline as you did with the footpad. If you use your original footpad, use that as a template. Now let's move on to the lamination layer. Basically here it's really up to you which effect you want to create.
For doing that, you have three choices. First, the area you want to cover with the lamination. Second, the thickness of the lamination. And third, which material you choose. I cover almost the whole area of the footpad with a big patch of carbon fiber. For that I use 200 grams per square meter 45-45 degree carbon, which means that the carbon fibers are laid on in two directions. That's where the by comes from. And the directions are 45 degrees to the 0 axis and 45 degrees in the other direction to the 0 axis. The white lines on the carbon is some random fiber that holds the carbon fibers in place. And under the heels I put some extra patches of the same fiber. In cases like these you want the fibers to run in as many directions as possible, so laying it on like this is not a good idea. Also like that is not a good idea because the fibers are laid in 45 and 45 degrees, so they will be in the same direction still. Also you don't want two patches to end in the same place, because that will create a boundary between a very stiff area and a very soft area. So I position the pad in an angle of 22.5 degrees and with the same offset on either side to this patch below. Carbon in comparison to glass fiber creates a stiffer footpad, which I like best. That's also why I put a big patch over the whole area of the footpad, and the extra patch below the heel makes it even more stiff and durable at that area. You could also use much more fiber to make the footpad stiffer and the shock absorption even better, but since my boards are quite solid already and I have an extra layer of footpad in the dent I shaped into the board, this is enough for me. To put the three components together, I saturate the fiber with resin. I didn't film this unfortunately, but I think it's a pretty basic process. You can see the saturated fiber in the top right corner of this picture. I do this in a separate area because I don't want any resin to go on the edge of the base pad, because that would make it difficult for the top pad, that is self-adhesive, to stick to the base pad. Then I prepare the top pad to stick it onto the base pad. Before you put the parts together, write some good wishes for your windsurfing progress on the base pad. Now I apply the saturated fiber. Remember to avoid resin getting on the edges of the base pad. Now put the top pad on. Take your time positioning it carefully. You don't want any air get caught inside the footpad. Also in this step you realize in case you use too much resin, so this is the last occasion to get rid of it. High pressure will improve the bonding of the self-adhesive pad, even if the pressure is applied only very temporarily. Pressure the pad with a weight and a plain piece of wood on a plain surface. Let it harden overnight. As you might know, for the full 100% of hardening you needed to temper the resin, otherwise it will take about a week to reach the 100%. But for this project it's totally fine if it only hardens to 95%, which takes about 20 hours. Of course, depending on the type of resin you use and on the temperature. When it comes to cutting out the footpad, a good template comes into play. With a wooden template this is much easier than with any other kind of template. Fix the footpad on the template with double-sided tape. It's absolutely no problem to cut out the footpad with a sharp knife. Doing that you can also put an angle on it like usual footpads have. But if you have the tool you can use a router machine like I do. For that you would definitely need a wooden template and a milling head like that or similar depending on your taste. Fix the template on your working place and then simply cut out the angle. Make sure to apply moderate pressure because the surface of the footpad is soft. If you are just looking to upgrade your original footpad with a base pad, I think it should look alright if you just cut out the base pad in a vertical angle. Now it's time to glue the footpad onto the board. By the way, in case my English is not the best, please don't be too hard with me, I'm a German. If you haven't done already, remove your old footpads from the board. This should be possible with a sharp tool like this one. It's called spattle, I believe. Take your time doing that to prevent damaging the surfboard or the footpad. If you don't want to reuse your old footpad, although it still looks alright, please don't throw it away. Put it in your cupboard, give it to a friend, because you never know when you could use it again, and footpads are always rare to find. Make sure to position the footpad carefully and draw a line around the edge of it. Tape along that line, you will see why later. In my case, that step is pretty simple because the footpad only has straight edges. Firmly press on the tape. Mark the screw holes for the foot straps and drill them with a wood driller with very moderate pressure. There are surely other ways to do this, but I found this the best way for me, and you won't be able to see the holes anyway once the foot straps are screwed on. When it comes to gluing the footpad onto the board, a lot of methods have been tried and a lot of frustration has happened, as I believe. I imagine that Sikaflex could be quite an okay way. I haven't tried that yet, but Pattex has proved to be a bad way. A way I use, since I figured out that it works quite well, is epoxy resin thickened with a stuff called microballoons. The microballoons change the viscosity of the resin to prevent it from flowing where you don't want it to go. However, if it still does, that's what the tape is for. Apply that with a spatula to the footpad and fix the footpad on the board. The big downside of this method is that the epoxy resin takes its time to harden instead of sticking to the board directly. And as a consequence, you have to apply pressure to the footpad at least 12 hours to make it stick to the board. That's easily possible with a vacuum pump, and that's also why this method is totally fine for me. While if you ask me, no household is complete without a vacuum pump, I assume that you unfortunately don't have one. And that's why I do it with tape here to show you how it's done without a vacuum pump, but it hurts quite a bit to waste all that tape. So if you know a method without tape or a vacuum pump, feel free to share it in the comments. After you have fixed the footpad in place with a little bit of tape and you have pressed it on with your hands firmly and made sure that no resin is pressed out to the sides, remove the tape around it and then use a lot of strong tape to apply a lot of pressure, especially on the edges of the footpad. The next day, all that's left is removing the tape. If you want to upgrade your footpads further with more grip, then click the video in the top left corner and...
By the way, if you want to learn more about the downsides of a soft deck and you want to learn how to repair it, then click this video. Otherwise, see you in the next episode. Thanks for watching.